Hey guys, today I'm going to show you how to process the image from the Motion Shot app for the purposes of doing this little mini lab that we talked about. So in front of you, you can see this is a picture that we took from Motion Shot. And so there's a bunch of different images of the tennis ball rolling down the incline overlaid on top of each other. And what you're going to do for each one of these is measure the distance from the edge of the paper to the center of the ball. All right, the first one I've got a really good shot at is this one right here. So I'm just going to go ahead and go through each of my images of the tennis ball and mark the center as, best I can estimate where it is. If you happen to have a blurry image, like it looks like it's stretched out, that's because of the shutter speed on your camera. Whatever, just, find the center of the blur, okay? All right, and if you have fewer than this, that's not a reason to be concerned. This is actually kind of a lot of pictures of the tennis ball. And if you've got like 12 of them on there and you're like, oh no, how can I measure all of it? You could skip and do every other one, perhaps. Or you could measure each individual one. The more you measure, the better your data. Okay, so here goes. I have my handy meter stick right here, and what I'm going to do with my meter stick is measure the distance again from the edge of the page. So, find the edge of the paper there. All right, so it looks like my first data point is at, it might look slightly different from your perspective, so you got to get right over it. This one looks like it's at 3.6 centimeters. So I'm going to write 3.6 centimeters right on there. The reason I measure in centimeters and not, say, inches is with the inches, those are in like 1/16 of an inch. And that's kind of hard to put into any kind of a graphing program. So you want decimal numbers because you can't graph 3 1/8 unless you then say, oh, 3 1/8, that's, and then you have to say an eighth is 0.125 inches. That's just an extra step. So rather than do that, we'll use the centimeter side of things. All right, so 5.9 centimeters. This next one is 8.7 centimeters. Again, this is always from the edge of the paper. Okay, so I'm not measuring distances in between. I'm measuring always from the edge of the paper. All right, you probably get the idea. So we're going to fast forward ahead a little bit. Now that I've got all my measurements on there, my next step is actually going to be to turn this into a table of values that I can put into some kind of a graphing program. I'll show you what app I want you to use to make these graphs in a little bit. But I mean, it could be any kind of thing like Excel, or even in your calculator, there's a place where you can input values. So here's our table that we're going to make. In one column, we're going to put time. You're like, time? I don't know how we can have time information because it doesn't say what moment that's okay. We don't need to know how many seconds there are in between each one. Our time really is not going to have any units here, okay? We're just using this to get qualitative data about what positive acceleration ought to look like for a distance, or displacement rather, versus time graph. All right, now one thought while I'm thinking about it. But Mr. Errico, I have a shot and the ball kind of bounces around the track. That's okay if the ball does that. Just measure the distance directly from the edge of the paper, okay? So that means you might have to go okay, from here, all right, again, from the edge of the paper, so ideally the ball would not be bouncing around the image, but if it does, it's not the end of the world, just again, measure from the edge of the paper. All right, so my first point here, I'll say that's time of 1, and it was at a displacement of 3.6 centimeters from the edge of the paper. My second data point, 2, 5.9. Third data point. Fourth data point. All right, so at this point you probably get the idea. If you've got 12 images of the ball, that's better, I would say, right? The more, the better. If you have only 4, I said in class that was enough, right? That's enough to give you the impression of what the data ought to look like. Okay, the next step, now that we have all that stuff right there, is to go to the graphing app that you're going to use. So what graphing app will we use, Mr. Errico? It's called Graphical Analysis, and it's the one with the 2 curves there. If you search for Vernier Graphical Analysis, let me write that down for you so you can understand how to spell that. Vernier, V-E-R-N-I-E-R, Graphical Analysis. Search for that, download it. It was one of the required apps at the beginning of the year, so you may already have downloaded it. All right, so in Vernier Graphical Analysis, oh, sorry, fumbling with the, all right, Vernier Graphical Analysis. Just wait for it to load. That's all. Okay, we're going to pick New Experiment. Now, Vernier Graphical Analysis is actually supposed to go with Vernier probes and stuff like that. We actually use Pasco mostly here. Whatever, that may not mean anything to you at this point. We're going to skip over all these options and go down to the bottom one, Manual Entry. And over here on the right side of the screen, you can see is a graph. It's not graphing anything yet because we have no data. And the left here, we've got a spot where we can enter in our data. There we go. All right, so if you double tap on it, then it allows you to enter the data points. Okay, so I'm going to go through and enter my data. So I hit 1, next, 3.6. That's where it was after, or for the first one that I picked. And then I hit next, and it automatically generates a new row. All right, so 2, next, 5.9. All right, you get the idea. All I'm going to do is go through and just enter every single one of those data points. All right, so let's skip a bit. All right, now I've got all my data points entered, and they conveniently graphed out right there. All right, next thing I'm going to do, and so everybody should, in theory, be able to get to the point of, all right, I've measured my points, I've put them in here, and they've appeared on the screen. The next thing that you're going to do is poke this thing down in the bottom left-hand corner of the graph. And what this allows you to do is figure out what kind of a graph you have. So if it's a linear graph, there's a particular curve fit that you can put to it. All right, I don't want linear in this case, okay? It doesn't really look like a straight line. As you can see, the line doesn't actually go through all the points. And ideally it would if you've taken good measurements. This one is supposed to be, since the spacing between the tennis ball changed in every frame of the image, should be quadratic. And sure enough, when I put it over to quadratic and poke anywhere else on the screen, that looks like a pretty good fit for a parabola. All right, next step in processing your data is you take a screenshot of this, and then you're going to print it just like you did in class on Friday. You're going to take the image, go to Notability, turn it into a full page. That may require rotating the image first, if you recall. Okay, so go to Notability, make it a full page, and print that out. All right, so then to recap, this will be in the directions for the assignment, but I'll say it right here because hopefully everybody watches the video to understand what to do. For each one of the experiments, you're going to have the image itself with those distances on it. So something basically just like this. Okay, so everybody's going to have that with the table of values next to it. And then you're going to have the actual screenshot printed out of the graph that you made in Vernier. So that's 2 things for every experiment, right? You're going to have this, all right, the printout, and then you're good to go from there. Okay. All right, if there's other things that you're asked to do in the handout, it would be answering some questions or sketching like qualitative graphs of stuff. But as far as quantitative, those are the only 2 things that you're going to have to print. All right. If that was everything you needed, great. If you have more questions, then you should see me before school on Monday, or at least before class on Monday, and I will hopefully be able to help you through all those things. Thanks very much.